We have already seen alcohols acting as nucleophiles in SN1 and SN2 reactions. So we've seen that alcohols themselves are weak nucleophiles, as evidenced by SN1 reaction, which generates a cation, and then a weakly nucleophilic alcohol such as methanol can eventually react to give us this ether through an SN1 method. And so alcohols themselves are weak nucleophiles, but they can be converted into better nucleophiles by deprotonation. So if we have ethanol and we react with sodium to get sodium ethoxide, then this will be quite a good nucleophile as well as a good base. And this will be able to react with a methyl iodide in an SN1 reaction to give us, again, an ether. And so we've seen alcohols quite a bit acting as nucleophiles. But the question is, can alcohols be electrophilic? And one could really think about it in terms of charges and realize that this is a delta plus carbon and this is delta minus oxygen, and this hydrogen again is delta plus. But this should be electrophilic carbon. The problem, however, here is that the OH minus is a bad leaving group. And even though carbon right next to it is electrophilic, it has a hard time expressing its electrophilic potential since the leaving group attached to it simply will not leave. And so the solutions to these problems are the conversion of the OH group into a better leaving group. One of those methods we've already seen, and that is a simple protonation, such as protonation with HBr, which will then give us protonated alcohol, and now water is a much better leaving group, which can be eliminated with bromine attack to give us this bromide as well as water. So that is one possible way to get to a good leaving. The problem here is the fact that lies in the fact that we need to use strong acidic conditions, which then tend to favor the formation of cations, which can rearrange. And alternatively, strong acidic conditions are not necessarily compatible with many other functional groups present in molecules. And so the question now is, well, is there a better way to convert an OH group or an alcohol into a good leaving group? And the answer lies in sulfonate esters. And so sulfonate esters are basically esters of alcohols with various acids that kind of look like sulfuric acid, except that they have some alkyl substituent here, which makes them soluble in organic solvents. And these esters will be created relatively readily from the corresponding acyl chlorides. And the R group can be a variety of things, but the ones that are most commonly used are these, which are so-called tosylates, as well as the simple methyl group in mesylate. Now, why are these leaving groups so good? Well, let's see what happens if we have an attack of, say, chloride or any other nucleophile here. Then our sulfonate will leave and give us our alkyl chloride, but it will leave as a negatively charged anion, which has a negative charge on oxygen, which is favorable. Although it's not only that, this negative charge can be localized over 3 other oxygens to give us a very stable anion. And this stable anion is a very good leaving group. And so this process of tosylation is immensely powerful method because it can be used to prepare almost any alcohol and set it up for a substitution reaction. Since alcohols are very prevalent compounds, this becomes very, very convenient. As an example of this, if we have, say, this benzyl alcohol and treat this with tosyl chloride, TSCl simply stands for, as an abbreviation for tosylate chloride, this thing. This is typically done in methylene chloride as a solvent in the presence of either triethylamine or some pyridine. And this is simply a base which is used to scavenge the HCl, which is from the side product. And so we'll get this benzyl tosylate. And now this benzyl tosylate can be easily reacted with, say, acetylide to give us our final product. This would have never worked with alcohol itself, because alcohol itself would protonate the acetylide. It would also not work under highly acidic conditions, because highly acidic conditions again would protonate the acetylide. And so this is where tosylates really come into play, where we can use virtually any nucleophile to displace them on a former alcohol base.